difference method or FDM. And I try to understand the FDM to you. And know that if FDM or finite difference methods are the fundamental tools for numerical solutions for PDE and ODE. The basis of a finite difference method is the Taylor's theorem. At this page, you can see the Taylor's theorem and together study this theorem. Let ux have the n continuous derivatives over the interval from a to b. You have n continuous derivative over from a to b. And for x0 and x0 plus h, that in this interval, it's busy. One of them, the round of one of them is very easy. Please silent your microphone to have a best voice from me. I want to introduce the Taylor's theorem to you. Let u have n continuous derivatives over the interval from a to b, and x0 and x0 plus h also is in the AB interval. Means a smaller than x0 and x0 plus h smaller than b. Means if this interval is from a to b, x0 and x0 plus h is in this interval. And the instance h, this means a step size. We called h is a step size. The Taylor theorem says u of x0 plus h equal to u of x0 plus h. The derivative of u respect x of x0 plus h squared uxx of x0 over 2 factorial plus 2 plus h power of n minus 1 u n minus 1 of x0 over n minus 1 factorial plus O of h power n. Please attention, in the left side, u is of x0 plus h, but at the right hand side, all of the function is of x0. ux0, the derivative of u of x0, uxx means the second derivative of u respect x of x0, and 2 u n minus 1 means n minus 1 derivative of u is of x0. Thus, the left side hand is of x0 plus h, but the right hand side is of x0. U subscript x equal to du over dx, u subs xx equal to round 2u over d2u over dx2, and u subscript n minus 1 equal to d n minus y u over dx n minus 1. This is ODE, not PDE. Why all of them is ordinary differential, not partial derivative? Why ux is ordinary derivative, not a partial derivative? What is your answer? Can I hear me?
Yes, hear you.
Yes, doctor.
Okay. As it was said before, when u is of one instant variable, the derivative is ordinary derivative. But if u of more than one variable, the derivative of u are called a partial derivative. In this part, u is only of x, then ux is ordinary derivative, not partial derivative, and we use d, not round. Round only use for partial derivative, not ordinary derivative. In ordinary derivative, we use d, not round. So du over dx is an ordinary derivative, not a partial derivative. Ux of xf, x0 is the derivative of u respect to x evaluated at x equal to x0. Ux of xf means the first derivative of u respect to x. U subs x, u subscript x, u با اندیس x. x means x اندیس u هست. پس u با اندیس x معنی مشتق اول u نسبت به x رو میده. اوکی؟ u subscript x means the derivative, first derivative of u respect x. O of h power n is an unknown error term defined in appendix A. Who is say to me what is the O of h power n? Based on the last session and the advanced numerical analysis. In advanced numerical analysis in the last session and in the last term, you understand the truncated error. Okay? Do you know, or yes or no? Do you know what is O of Hn? What is O of Hn? What the means of O of Hn? Do you know, yes or no? In the advanced numerical analysis, in the last term, you should understand this topic. Truncated error. Okay. Okay. I will continue. The usual interpretation of Taylor's theorem says that if we know the value of u and value of its derivative, please see the Taylor's theorem. If we have the value of u and ux and uxx and any derivative of u respect x of x0, we have the value of u and all derivative of u at x0, then we can compute the u of x0 به اضافه plus h. اوکی؟ بله، یعنی ما u و مشتقات u رو در نقطه x0 داریم در سمت راست. حالا به کمک اینها u رو x0 به اضافه h حساب میکنیم. پس ما مقدار u رو و مشتقات u رو در نقطه x با اندیس 0 داریم. حالا میایم از سمت راست استفاده میکنیم و مقدار u رو در x0 به اضافه h به دست میاریم. میس زینب is in the class. میس زینب، میس زینب طلیب، are you present? Are you in the classroom? Okay. But I think Miss Zainab hasn't my voice. Okay, I will continue. When we say O of h power n, we say that order of h is n. N is the order of h, order h to the n. We can use the Taylor theorem to find the finite difference method. I have an exercise. If we have, please solve this example. This plus x minus 1, and please compute u of 1.1 by using Taylor theorem, and you put the x0 equal to 1. Please write this exercise. Write the exercise. Okay. It is a Taylor theorem. You should use this theorem and compute u of 1.1 by using x0 equal to 1, and use three term of right hand side of this theorem. It is only used as three term, means u of x0, hux of x0 plus h squared uxx of x0 over 2 factorials. Please use only three terms of the right hand side. Please, all of them solve this exercise and send to me your solution via WhatsApp in PV, not in the group. In PV, send me your solution of this exercise. This. I'm pointing to the exercise. Can you see the exercise? I've written by the pencil at the end of the page. Start. Compute. This is u and compute u of 1.1 by using Taylor theorem and put the x0 equal to 1 and only use the term. You have 5 minutes to solve this exercise. Please, all of them try to solve this exercise. Yes. In PV, not in group.
يعني هسه تريدها المعادلة. وينها المعادلة؟ وينها؟ وين؟ تمام.
Using Taylor theorem, I solve this exercise and select another exercise to you next. Okay? I solve this and then you select another example for you to solve it. I write the u of x raised. I've written to you ux equal to its power 3 or 4 plus x minus 1. Is it okay? Yes or no? Yes. And 4 or 5, x3 or x4? x4 or 3? x4, no problem. I correct this. You have x equal to x power 4 plus x minus 1 and x0 equal to 1. Okay.
Yes.
For the Taylor theorem, we need u of x0, ux of x0, uxx of x0. I say that use only 3 terms of the right-hand side of Taylor theorem. Only I should use these three terms, okay? Only until uxx of x0 over 2 factorial, okay? Then we need to compute u of x0, ux of x0, and uxx of x0. Okay, I should compute derivative of u, the first derivative, and the second derivative of u. When u is x4 plus x minus y, ux means the first derivative of u respect to x equal to 4x3 plus 1. Okay. And the uxx means the second derivative of u equal to 12x x2. Okay? And compute uxx. Okay? And then I should understand xx of x0. x0 is 1. U of 1 is equal to, I should replace x in ux by 1. Then we replace 1 instead of x. I have 1 plus 1 minus 1, and the result is 1. Okay? ux of 1, I should compute the derivative of u respect x at 1, and we should put 1 instead of x, and we have 5 for ux of 1. uxx of 1, I should replace the 1 instead of x, and we have uxx of 1 equal to 12. Okay?
Okay.
And then I write the Taylor theorem. The exercise asks me about u of 1.1 by Taylor theorem. When we have 1.1 and x0 equal to 1, means x0 plus h equal to 1.1, okay? And x0 is 1. Then 1 plus h equal to 1.1. And then we result that h is 0.1. It's okay? This part is okay for you? Yeah, 1.1 is x0 plus h. And the problem, the exercise says you put x0 equal to 1. Then x0 is 1, and the x0 plus h equal to 1.1. And then we obtain that h equal to 0.1. And finally, we should replace all of them in the Taylor theorem. Please let me erase this part, and we have free space to write. x0 plus h is u of 1.1. It is what that I try to compute it by using Taylor's theorem. Equal to ux0. ux0 is u of 1. That we have the result of it is 1. x0 is u of 1 because x0 is 1. And we compute u of 1 is equal to 1. Then I write 1 plus h. H is 0.1. Then I write 0.1 ux at of x0. We compute this and obtain the result is 5. 0.1 times 5 plus h2. H is 0.1 and h2 is 0.101. Okay, times uxx of x0, uxx of 1 is 12 times 12 over 2 factorial, that is 2. And compute these terms, and then we have approximate the u of 1.1. 1 plus 0.1 times 5 means 0.5 plus 0.01 times 12 over 2 is 6. 6 times 0.01 is 0.06. And then I obtain 1 plus 1.56. Okay, it's an approximate to u of 1.1 by Taylor's theorem. But the exact solution of u of 1.1, I compute exact solution, and I should use the formulate of u for compute the u of 1.1 equal to u is x4 plus x minus 1. Then I compute 1.1 power 4 plus 1.1 minus 1 is okay, is the exact solution, not by using the Taylor theorem. It's the exact solution, and I'm going to compute the error of this computing. Okay, I should compute 1.1 power 1.1 power 4 plus 1.1 minus 1, and the result is 1.56 4, 1. It is the exact solution, okay? Is it clear for all of you? Is it the exact solution? Because I put the 1.1 at the formulate of u, okay? But 1.56 is the approximate solution because I use the Taylor theorem and use only three terms of the right hand side, okay? I use only three terms of the right hand side of the Taylor theorem, and 1.56 is approximate solution, but 1.5641 is the exact solution. The difference between the exact solution and the approximate solution is the truncation error. What the error of this computing? What is error? What is the error? Error equal to 1.5641, the exact solution, minus the approximate solution, 1.56, and the result is 0.0041. This is the error of this computing. If you have any question, please ask. Yes, you should. If we have u, we can use the error. The exact solution minus the approximate solution means the error. Okay? All of them is okay? All of you is okay? Understand this exercise? Do you understand this exercise? One point one. At this part, replacing in the Taylor theorem. Replacing in the Taylor theorem, okay? Okay, please let me open the whiteboard and write another example to you for solving. And try to open the whiteboard. Can you see my whiteboard? No. Share. And now? No, at this time, at now. Use four terms. Use the four terms of Taylor theorem. Taylor theorem. Yes.
Okay.
To what I solve for you. four terms of Taylor theorem باعث قضیه تیلور. خب please write this exercise that I go to the next page and write for you the Taylor theorem. Of x0 0 plus h equal to u of x0 plus h u subscript x of x0 plus h power 2 u x x of x0 over 2 factorial. These are three terms, okay? The next term is h power 3 u x x x, the third derivative of u respect x of x0 over 3 factorials. It the approximate of u x0 plus h by using Taylor theorem by using 4 terms of Taylor theorem, okay? You should compute Taylor by using Taylor and by using the formulate of u. Please send me via WhatsApp in PV. You have time. UXX for UXX, okay? I check your solution. Miss Sima Hassan, your derivatives, and then you should only use 4 terms of the Taylor theorem, and then you compute the third derivative of u, not higher order of derivative. Only you should compute the ux, u second order of the second order derivative of u, and the third order derivative of u. If we say to you, use 5 terms of the Taylor theorem, you should compute until the 4th derivative of u. Is okay for you? Is it okay? I say to you, use 4 terms of Taylor, okay? 4 terms of Taylor's theorem, not 5 terms, not 2 terms, not 3 terms. You should only use 3 terms, ux plus h uxx over 2 plus h2 uxx over 3 factorial, okay? Because you should only use 4 terms of Taylor theorem, not a higher order of derivatives. Last exercise, the last example, I say to you, use three terms, okay? In this example, I say to you, use four terms, okay? Then, okay, because we should use four terms of Taylor theorem, I should compute until the third order derivative of u. At the example, I say to you, put the x0 equal to 2, okay? I'm erasing the page for write the computing. Okay. And when we have a ux equal to 2x5 minus x plus 1, ux is equal to, the first derivative is equal to 10x4 minus 1. It's okay? And uxx, the second derivative of u respect x, is equal to 40x power 3. Yes, it's okay. And then x, 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 the third derivative of u respect x equal to 120 x2. Mr. Simo Hassan, the third derivative of u is not okay. Please check your solution. Okay? I don't have checked. Is it okay until this part? Is it okay? The exercise says get x0 equal to 2. Okay? And for Taylor theorem, I need u and ux and uxx and u triple x of except means of 2. U of 2, you should replace 2 instead of x. Then we put x2, we have 2 power 5 times the 2, and the result is 63. And ux of 2 is equal to 2 power 4 is 16 times 10 minus 1. 2 power 4 first, and then multiply 10, and the result is 159. uxx at 2 equal to 2 power 3 is 8, and the result is 320. And the u triple x, or the third derivative of u at 2 equal to 2 power 2 is 4, multiply 120 is 480. Okay? Is it okay?
Okay.
Okay. Then we should replace this 4 result in the Taylor theorem. I go to the next page and continue my computing. Based on the Taylor series, ux0 plus h is approximate by ux0 plus h ux x0 plus h2 ux x of x0 over 2 factorial plus h3 u triple x of x0 over 3 factorial. We put x0 is 2, okay? And we approximate u of 2.2, and 2.2 equal to 2 plus 0.2, and then we have h equal to 0.2. Okay? The problem at the last page, we want to approximate u of 2.2 by Taylor theorem, 2.2. And the x0 is 2, okay? Then we can write 2.2 is equal to 2 plus 0.2, and then we obtain h is equal 0.2. Is it okay? And then it's sufficient to replace the result at the last page in the Taylor theorem. U at 2.2 is approximate by u of x0 at the last page. We obtain that u of 2 is 63, okay? Plus, then we have put h. H is 0.2, and then write instead of h 0.2 times ux at x0. At the last page, we compute that ux of x0 means ux of 2, and the result was 159, okay? Plus h2, h is 0.2 over 2 over 2 factorial is 2. times uxx at x0, and the last page uxx at x0 means uxx of 2, and the result is 320. And the last term is h3 means 0.2 power 3 over 3 factorial is 6. Then we should write 0.2 power 3 over 6 times uxxx at x0 at the last page, we obtain 480. 480. Okay, the result is, please say me the result. Please say me the result. Please compute this and say me the result. The approximate solution. I want the approximate solution of you. Miss Zainab Taleb compute, and her result is 101.84. Okay? Okay. Until this, we compute the approximate solution by using 4 terms of Taylor's theorem, and 101.84 is an approximate solution for u of 2.2. At the next page, I'm try to exact solution of u. I want to exact solution of u of 2.2. For the exact solution, I can't use the Taylor's theorem, okay? I should use the formulate of u, means ux equal to 2x5 minus x plus 1. We should use this formulate for the exact solution, okay? And we put x 2.2. When we replace x by 2.2, and then the computing, we have obtained the exact solution. Then for the exact solution, we use 2x5 minus x plus 1. I should go to the, okay, ux is equal to 2x5 minus x plus 1. When we put x by 2.2, the exact solution of u at 2.2 are computed, and it's equal to 2. Replace x by 2.2 power 5 minus 2.2, okay, plus 1. And the result is, 101 dot 87 or 7, I think 87. Okay. 72. Is it 6? Only 4 digits is okay. Okay. Then, until now, we compute the exact solution and the approximate solution. And we have to compute the error. What about error? What about error? Please, what is the error? What is the error? Okay. Please describe. The error is the difference between the exact solution and the approximate solution. Okay. The error is the difference between the exact solution and the approximate solution. For the error, we should minus the exact solution from the approximate solution. At this page, I compute the error. The error is equal to 101.8726 minus 101.84. And the result, when we compute this difference, the result is what the result? What the result? The result is 0.0326. اوکی. خب بچه ما توی این مثال قضیه تیلور رو گفتیم و تونستیم باهاش تابعه ها رو تغییر بزنیم. At this example, you understand the Taylor theorem, and we can compute the exact and the approximate solution by using the Taylor theorem, and then we can compute the error of our computing. Okay. Please let me to share the book and continue the lesson. The Taylor theorem put a finite difference method, and they use the some terms of the Taylor theorem to compute the relation or approximate the solution of the derivative. For example, when we use the first derivative terms at the right side of the Taylor's theorem, we have u of x0 plus ux0 plus h ux plus OH2. Okay, it is the Taylor theorem that we have used only two terms of the right hand side of the Taylor theorem. U are ux0 and ux of x0. We have used only two terms. Ux is one term and hux of x0 is the second term of the Taylor series at the right hand side. We use only two terms of the of Taylor's Taylor theorem, and the 2.2 is the approximate of u of x0 plus h when we neglect OH2. We can rearrange the 2.2 and we have obtained the ux of x0 equal to ux0 plus h minus ux0 over h plus O of h2 over h. Is it okay for you or no? This expression is the 2.2 that we rearrange the writing. Only 2.2 solve for ux of x0, and we have the approximate solution, approximate formulation for the derivative of u respect x. Let's see. Then we have ux0 plus h equal to ux0 plus hux of x0 plus OH2. ux0 go to the left hand side, and we have ux0 plus h minus ux0, and the right hand side of the 2.2 is h ux, the first derivative of u at x0 plus OH2. Okay, is it okay? Only we put the ux0 from right to left. Okay, then divide both of them by h, and we have ux0 plus h minus ux0 over h is equal to both terms of the Taylor theorem should be divided by h. Both sides of them divided by h. And we have h simplify, and we have OH2 over h is O of h. The order of error is 1. The first order error it's occur. It's OH. When we have neglect the OH, we obtain the approximate formulation for derivative of u respect x, and we have ux at x0 is equal to ux0 plus h minus ux0 over h. It's called the first order finite difference approximation to ux over x0. It's a first order approximation for the first derivative of ux. Is it okay for you? Is it okay? Okay. It's called this formulation is called a forward finite difference approximation because we can compute the u at x0 by using u at x0 plus h. We need use u at the next step at the x0 plus h for computing the ux at x0. We use u at x0 plus h and u at x0 to computing the derivative of u respect x of x0. Why why is called a forward finite difference approximation? What about your opinion about this? Why we call this formulation forward finite difference approximation? Why forward? Why is not backward? Because we want to to approximate the first derivative of u at x0, but you should use the u of x at the next point. x0 plus h is the next point after x0. Okay, x0 plus h is the next point after x0. Then by this reason, this formulation is called a forward finite difference approximation. This formulation is a forward finite difference approximation. When we say to you first order forward approximation for you, you should answer me ux of x0 is equal to u of x0 plus h minus u of x0 over h. It's very important. It's the main step to understand the finite difference approximation, finite difference method. In this formulation, we compute ux by using u, not ux. I want to compute ux and I should use u at x0 plus h and u at x0. Okay? For example, let ux equal to x2. I want to solve an example by using this forward finite difference approximation for the first order derivative. Let ux equal to x2, ux equal to x2, okay? And the problem says step size h, put h is equal to 0.1. And by using the 2.3, we want to computing the derivative of u at 3. The first example I explained for you, and the next example, we should solve it. Please attention to me. We have, by the above formulation, based on the above formulation, we have the forward finite difference approximation for the first derivative is u x0 plus h minus u x0 over h. Is it an formula? Is it a formulation for computing approximately of ux, the first derivative of u? Okay? When we have u equal to x2, then u of x0 plus h is x0 plus h power 2, okay? Because u of x is x second power of x or x2, and u of x0 plus h is x0 plus h power 2, okay? And u of x0 is x0 power 2. And for this example, we have ux, the first derivative of u respect x at x0 is approximated by x0 plus h power 2 minus x0 power 2 over h. Is it okay until this part? Yes or no? Okay.
Yes, Doctor.
Then, okay, very good. Then we have used ux means the first derivative of u at 3. It is sufficient to put the x0 by g by 3. Okay? ux and 3 is 3 plus 0.1 power 2 minus 3 power 2 over 0.1. What is the 0.1? What is the 0.1? Why is what is it? It is h. Please be careful. It is h. x0 plus h. At in this example, we should use h equal to 0.1. And when we have h is equal to 0.1, we use it at this formulation. And we have ux3 is approximated by 3 plus h power 2 minus 3 power 2 over h, and the result is 6.1. It's an approximate solution, okay? It's an approximate solution by using the first order forward finite difference approximation. It is an approximate solution. What about the exact solution of ux at 3? What the exact solution? Exact solution. U of x is equal to x power 2, okay? U of x we have is equal to x2. What about ux of x, the first derivative of u respect x? Ux of x to x, okay, is equal to 2x, okay? We have the exact solution of ux at 3. 6, okay. The exact solution is 6, okay? And the approximate solution is 6.1. ux at 3 by the forward finite difference method is 6.1, okay? And the error is 6.1 minus 6, and the error is 0.1. Okay, the difference between approximate solution and the exact solution is the error, and the error is 0.1. Okay, for the another example, we suppose that we have solved this example by using h is equal 0.05, means that h is changed. We have changed the h, and we want to solve this example again. The formulation not changed. The formulation is the same, and ux3 is equal to this formulation. You should use this formulation again, okay? But we should use h is 0.05 instead of 0.1. The computation is repeat again, similar the last part, and we should compute 3 plus 0.05 power 2 minus 3 power 2 over 0.05, and then we have the result is 6.05 is the approximate solution. It's approximate solution, and the exact solution not change. The exact solution always is 6, and the error is 6.05 minus 6, and the error is 0.05. Okay. I have a question from you. Which of them is better for approximate solution? Which approximate solution is better? When we use h is 0.1, the approximate solution is better, or when we use the h is equal to 0.05, the approximate solution is better. When we use h is equal 0.1, the error is 0.1. And then when we use h is 0.05, the error is 0.05. Which of them is better? First or second? Which error is better?
Second.
Yes, the smallest error is the best error, okay? The smallest error is the best error. And it is very clear that the second edge is the better for approximate solution. Means when we have choose the smaller edge, we have obtained the better approximate solution. A smaller edge give the better approximate solution. Okay. I want from you to solve the derivative approximately by using the forward finite difference method. Please suppose that u of x equal to x3 minus 2x plus 3. Okay? Please approximate the first derivative of u respect x at 2. Approximate this by using the forward finite difference. Why the approximate solution of ux of 2? By using a first order forward approximate solution. Please put h is equal to 0.01. Please solve this problem and approximate u respect x of 2 and then the error of this computing. Okay, please solve this problem at now and send to me your solution via WhatsApp at PB. Okay, I'm waiting. Please, all students, so try to solve this problem. Mr. Ahmad Khalil, Mr. Hassan Isa, Mr. Adnan Salman. Also try to solve this problem. Miss Zainab Taleb send me her solution, and I'm checking her solution. X of x is h plus. Please compute the result, Miss Zainab Taleb. Please compute the result. Of u respect x, the first order finite difference method. The forward finite difference method is u x at x0 is approximate by u of x0 plus h minus u of x0 over h. Okay, and for this example, we should write u. We have x0 is equal to 2, and the h is equal to 0.01, and then u of x0 plus h is 2.01. Okay? Okay. Minus u of x0 is u of 2 over h is 0.01. Okay? Then we should compute u of 2.01 and u of 2. U of 2.01 equal to 2.01 power 3 minus 2 in 2.01 plus 3. Okay? And the result. Everybody, please pay attention to me. At result, you use at least 4 digits after point, not only digit. Only the 1 digit, it's very bad approximate, it's very bad computing. You use at least 4 digits after point. And when we use 4 digits after point, we, we have what? What we have? The result is 7, okay? $7.1006. It's okay? And u at 2 equal to 2 power 3 minus 6 plus 3. Okay. Please compute the u of 2 again. U of 2.01 again. Please compute this. 2.10 power 3 minus plus 1. Excuse me, it's not 7, it's 5. I correct it, 5. Yes. 1.1. Yes, please, please let me erase. Excuse me, my pencil is black and try to solve the problem. My pencil is black. What number do you find? The result is 10.06. Okay? Is it the approximate solution for you respect x at 2? Okay? What about the exact solution of ux at 2? When we have u is x3 minus 2x plus 3, the u respect x, the exact derivative of u respect x is equal to 3x2 minus 2. Okay? Are you in the classroom? Yes or no? The exact derivative, we should derivative of u respect x. The derivative of x3 is 3x2. The derivative of minus 2x is minus 2. The derivative of 3 is 0. And the ux of u is 3x2 minus 2. And the exact solution of the derivative of u at 2 is equal to, we put x by 2 and the result is 10. The exact solution for for ux at 2 is 10 and the approximate solution of u is 10.06. Okay? And the error, for the error, we should compute the difference between approximate solution and the exact solution. And then the error is equal to 10.06 minus 10, and the result is 0.06. Okay? And this is the error. Are you understand this exercise? What is the difference between exact solution and approximate solution? The exact solution, we use the exact derivative and put the x by 2. But by approximate solution, we use the first order forward finite difference method and compute the formulation by using x by 2, and then the result is 10.06. And for error, we compute the difference between approximate solution and the exact solution. Okay? It's okay for today. At this session, we have wanted to understand the difference between exact solution and approximate solution. You should understand the difference between exact solution and approximate solution. And if you have any question, please ask. Do you have any question? Do you have any comment? Do you have any problem? I will send you some exercise in the group at a few days, not today, not Friday, not tomorrow. At a few days, as soon as possible, I send to you some exercise, and you should solve them, and then send to me your solutions. Okay? Okay. No problem. Okay. Goodbye. امشب شب احیا هست برای شما. امشب شب احیا هست. شب پرفیض و برکتی براتون باشه. And goodbye. Goodbye.